Okay, properties of logarithms. There are quite a few properties to learn and then to be able to use. So I'm going to list out the names of them, what they are, and then a few little examples as I go through. And then it's going to be time for you to practice in class. So the first one is if you have log base b of 1, that's always equal to 0. And that's true since b to some power to be equal to 1 would mean that b to the 0 is what's always equal to 1. So there is our first log rule. The second one is if you have log base b of b, you always get 1. And that one's true because b to the power of 1 would be equal to b. So base b, that's that b right there, to this power of 1 is equal to this b value right here. So knowing the definition of the logs from last day is really going to help understand some of these other properties of logarithms. Okay, the next one has a name. It's called the product rule, and it states that if you have log base b of a couple of numbers multiplied together, then that's the same as log base b of a plus log base b of b. And the reason that that one works is because it's essentially equivalent to this old exponent rule that if you have b to the x times b to the y, then you get b to the x plus y. And an example of the product rule would look like this. Log base 4 of 2 plus log base 4 of 8 would be log base 4. So the bases don't change. You see b all the way across there. And 2 log base 4 of 2 plus. This plus sign is the indicator that it's going to become multiplication. So you're going to get 2 times 8 or log base 4 of 16. And we can actually solve that if we were continuing to do this. To solve this, I'm really solving the question 4 to what power is equal to 16. So that's what I think about, and the answer is 2. Okay, if there's a product rule, there is a quotient rule, so that'll be our next one. And essentially the quotient rule says instead of multiplying, if you do division, then instead of adding, you get subtracting. So an example of that might be log of 12 minus log of 6 is the same as log of 12 over 6, or log of 2. And you can verify that. Just grab a calculator, do log 12 minus log 6, see what decimal place you get, and then do log 2 and see what decimal place you get. Okay, let's move on to the next rule. It's called the power rule. And the power rule states if you have log base b, a to the n, that n basically drops down in front. It becomes n log b to the a. And an example of that would be if you have log base 3 of 81, you can think about that as log base 3 of 3 to the 4th. This 4 can drop down. And as we saw with the second rule, that's equal to 1. So the answer to log base 3 to the 81 is 4, and I could have just gone straight to there by thinking about 3 to what power is 81, and it's actually 3 to the 4th is 81. So I could have done that as well. I just wanted to show you how it works as a power rule. One of the most powerful rules, it's really great for our calculator as well, is called the change of base rule. So perhaps you've got log base b of something and you don't want it in that base anymore. You've got it in base 3 and you're like, I don't want to work in base 3, I want to work in base 5 or base 10. Well, there's a great little rule that allows you to change the base to whatever you want to change it to, and then all you need to do is take the a value on the top and that base value on the bottom. And this is one really powerful rule. Log base b of a can be split up into log base x of a over log base x of b. So x is a base. You can choose whatever x value you want to be the base, but it has to be the same on the top and the bottom when you choose it. So if you're going to choose base 7, both of those x's have to be 7. But you are allowed to choose it to be whatever base you want. And where this is really helpful is when you want to, say, calculate log base 3 of 4 to 3 decimal places. Well, you'd have to guess 3 to some power is equal to 4 until you got 3 decimal places of that. And it's like 3 to the 1 point something, and you'd be guessing and guessing and guessing. Or you can say, well, log base 3 to the 4, I have a calculator button that works in base 10. So if I change this to log base 10, we don't write the tens, and I have a 4 on the top and a log base 3 on the bottom, so those are base 10s. The x is equal to 10 in both of these cases. I can just calculate this on my calculator. So log base 4 divided by log base 3 and get 1.262 to 3 decimal places. That's a whole lot faster than trying to guess and check this equation over here. It actually doesn't matter what base you work in. So if you want to be fancy, you can do lns and do ln 4 over ln 3, and ln's a good one because your calculator has a button for it, and you will get the exact same answer. It doesn't matter which base you change these things to, they're still equivalent. Okay, so with these rules, we should be able to do some other kinds of simplification. So let's take a look at this example, where our instructions are to expand this log, which is all put together, which is log root 3x over 4. And to expand this, let me think about this as log of the 3x to the 1/2, all divided by 4. And let's start using some of the rules to break this apart. Well, the division of these things can be rewritten. So this is 1/2 minus log of 4, and it's all base 10. Then this 1/2 can come down, so I get 1/2 log of 3x minus log of 4. And this 3x can be broken into two pieces, so 1/2 log of 3, and the 1/2 also will apply to the log of x. So when I split this 3x into two pieces, this 1/2 multiplies both those pieces, and log 4. So that's my final answer, as this piece of logarithmic math expanded out into all of its component parts. So if we can do an expand question, we can also do what's basically called a simplification question. So you can take something that looks like it's in an expanded form and try and put it back together into a single log form. So this 1/4 will be the exponent, so this is log x to the 1/4, plus this 3 will become the exponent, so log x minus 1 cubed. And this multiplication, this plus sign becomes multiplication when I bring them together. So I get x to the 1/4 times x minus 1 cubed. And there it is, tightly together. If you want, you can change this to the 4th root of x times x minus 1 cubed and take it out of that exponential form. Okay, there are a few other helpful shortcut rules. They're not as necessary to know, though they are really good to be able to kind of skip some steps. especially if you're working with really complicated logs. So I'm just going to list those here. And my advice with these log rules, because there's just so many of them, is to make up a little cheat sheet or some flashcards and be practicing them so that you can recall them quite quickly. So here they are. The first one is if you have b to the power of log base b of a, you just get a, as long as a is positive, of course. If you have log of b of a, that's the same as 1 over log base a of b. Just kind of a neat thing. The base and the number switch. Log base b of a can also be written as negative log 1 over b. So the base switches and you get a negative sign in front, and the a stays the same. So there are 3 rules. If you have log base b of 1 over x, you can get log base b of x, and that one's kind of easy to see because this is x to the negative 1. That negative pops down into the front. So I'm basically just using the other log rules to build these shortcuts, which is why I say you don't have to know these ones, but they will save you some time. Log base a of x over log base a of y. This looks similar to the change of base rule. In fact, it is. You can change it to any base. So if you want to switch bases and it's already in that change of base rule, you just kind of switch the bases. And log base b of x will be equal to log base b of y only if x is equal to y, which kind of brings us back to the very first thing that we looked at when we were doing some of the definitions. Okay, so there's some extra log rules that you can learn as well, and be ready to do some practice in class.